chapter, what are we on? Chapter 5, I believe, methods. Any questions before we get started? Okay. So methods. What is a method? Well, I guess they're actually going to first open up with a problem by saying that to find the sum of integers from 1 to 10, from 20 to 30, and then 35 to 45 respectively. So what they're going to do is they're going to present you with a problem here showing that this is probably how you would do it. And it's essentially the same code we're doing 3 different times. So the problem is you're repeating all this code. And for 2 or 3 times, that's not that big of a deal. But what if you needed to do it 20 times or 200 times? Repeating the code is not very good. And you probably could encase the entire thing within a nested loop. That would actually probably fix your problem as well. But there's actually a better way. There's something called a method. And a method, well, let's go through this again. So here's the problem. This code is all duplicated, essentially. So what is a method? They're showing you a method here, public static int sum. And this probably looks a lot like methods you've already seen, like the main method that you need in order to run a program. Like public static void main, this is a method. But you can have more than one method, and I think we already showed this a few weeks back. I did an ad hoc program where we did this back. So what a method does is it's essentially a named block of code. And remember that a block of code is more than one command, right? So a method is like a named block. And it's got some other properties as well. But it's basically a named block. And because it has a name, you can, what we do, say, call it. You can call it that. If it's got a name, you can call it. And we can look at, do I have this example? I'm not sure if I have this example. Certainly do this. And I'll just call it solution, because that's what they call it. Let's see. So here it is, and we'll run it in a second. It is a named block of code. So here's the block itself, and we're giving it a name, which allows us to call it. And I put the main method afterwards intentionally to show you that objects do not need to be linear. Not linear. They do not have to be sequential. So when we run this thing, Java always looks for the main method, and it doesn't matter where in the class it is. It's just going to look for the main method. Now, in the main method, we're calling our custom method. Sum is a method we wrote, so it would be a custom method with 2 values, or parameters, or arguments, often called. And those will be received here, and we're going to do something with it. And what we're going to do is we're going to use a for loop to sum them up. So you're taking 2 numbers and you're going to sum up the range of those numbers. So 1 to 10, 20 to 30, 35 to 45. And then we get that output. So again, this was main as our starting point is always our starting point. Wherever in the file it is, main is always the starting point. Is calling sum 3 times. And that's a lot less programming than having to copy and paste these for loops 3 times. Any questions on that example? We've actually done some other methods examples before. So what we're looking tonight is we're going to talk about formal parameters, and I showed you what formal parameters are. These guys right here, int I1 and int I2, are formal parameters. They will receive the values of 1, 10 the first time, 20, 30 the second time, 35, 45 the third time. We'll define return type. In the case of sum, the return type is an int. It's going to return a numeric value, whole number numeric value. You can define methods without a return value. Main itself is essentially one of those methods because it's declared as void. And void means I'm not going to return anything. Int up here, right before the name, means I'm going to return a whole number. We'll look at something called passing arguments by value. That's basically automatic, but we'll talk about it. And methods, part of the reason you create methods is methods are a smaller unit of an object, and they make things modular, easy to read, reusable, and easy to debug, and maintain. So they're essentially, if an object is a larger person, place, or thing, a method is a specific thing that object can do. So, if you think of an object as being a person, what are its methods? Well, sleep is a method, right? Eat is a method. So these are things that the object can do. To write a method that converts decimal, well, we'll look at a couple of different coding examples. We'll talk about something called overloading methods and the ambiguity that can cause a little bit later. Another thing called the scope of a variable, or the life of a variable. How long is that variable available in memory, and where is it accessible? Who is it accessible to? That's all the scope. We'll look at the math class again. We've already looked at it, but we'll look at it a little bit more. And then we'll look at some design methods and abstractions and see how to design and implement methods from a design document. Okay, so if we define the method here, we're saying that, and this gives you a good breakdown of the whole thing, is and a method is really designed to do one very simple thing. A method should not do multiple things. It should do one fairly simple thing. You have different modifiers. So what's modifiers? Generally will specify permissions and how the method can be used. Public means it's publicly accessible, including outside of the class. Static means that there's only one copy of them. More on that later. Think of static. The S in static is meaning single copy. It belongs to the class. Later on, when I talk about your Lab 3, we'll talk a little bit more about class versus an object and instantiating an object from a class. This static thing comes into play there. So more on that later. The return type, which is an integer. The name of the method, which is max. The formal parameters. It takes the first parameter. It takes two parameters. You just count them. There's 2 commas there, so there's 1 comma there rather, so that means there's 2 methods. Int num1 is the first one, and then int num2 is the second. Then we have the body of the method, and that's basically the block or everything the method's going to do. In this particular case, it's looking for a max value, and it's going to be a fairly simple if statement. This probably could have been done a little more efficiently, actually, but you didn't need the temporary int. I could have done that a little more efficiently. But anyway, to keep it simple, it's basically saying if num1 is greater than num2, then it assigns num1 as the greater or the max of the two to result. Otherwise, it assigns num2 to result, because num2 would be the greater of the two. And then here is using it. Int z equals max x comma y. That would be actually using it. Much like we saw in this example here, the method being used here. So here it's something called the method. We'll go through it a little bit more detail. The method signature, and this is important to remember because it comes into play later on when we talk about overloading a method. Overloading a method, and more on that later. But is that the method signature? We say here that this is the method name, and that's true. But the method name alone does not necessarily uniquely identify the method to Java. What recognizes or what uniquely identifies it to Java is its entire signature, which is the name along with the formal parameters. So the uniqueness of this method and how Java determines how to call it is its name and its formal parameters. Okay, so that makes up the method. And a little more on that later. We'll just keep that in mind that a method has a signature, and this is what it is. And then later on, when we get into overloading, we'll see why that's important. The formal parameters, these are the names of each parameter. These are actually variables. It would really be as if you declare these variables locally. They don't really need to be redeclared. They're available here. Okay, so these are the arguments you're passing to it. So in general, passing the value to a method, you say we give it an argument. The receiving end, on the receiving end, so on the giving end, it's generally called an argument, but then on the receiving end, it's generally referred to as a parameter. And most people use this stuff interchangeably. They call arguments and parameters, and I do too, interchangeably, so they don't really make a distinction as to whether it's on the receiving or sending end. But technically, if you're sending the value, it's an argument. If you're receiving it, it's a parameter. I would never ask that on a quiz. I don't bother with it myself, so. But just for your information. Return value. This is what you're going to return to it. It always has a return statement and then what you're going to return. And the data type of the return value has to match the return value type here, int. In this case, whole numbers, whole number. And that's what we're returning. The result is an int, as it's declared up here. And all these parameters are integers as well, so there's no real issue there. Everything's an integer, so we're returning that int. And I think I have this test max example. Is there any questions? Do I not have test max? I thought I did. Test. Okay, maybe I don't have test max. But max would really be. Let's go. Where was it at? Some. Let's see if this works. Well, actually, let's just do it here. Well, this will work, except that it's